So in this tutorial we are going to do the linked list implementation of stacks. In the previous tutorial we have already covered the array implementation of the stacks. So the new information that I want to give you is that stack is an abstract data type, and by the meaning abstract data type, or by this ADT, we also call it as ADT. So stack is an abstract data type, and this means that stack can be implemented using linked list or some other data structure, but you will have to follow the LIFO principle. So if you are following the LIFO principle, that is, you are doing the insertion and deletion operation at the same end of any data structure, then you can call it as a stack. So in this tutorial we are going to do the linked list implementation. So let's suppose we have a linked list like this, and this linked list contains 3 elements, and from the knowledge of linked list, which we have already covered before, we know that this is the next pointer and this is node, and the next pointer of the last node will point to null. So let's suppose this is a linked list that contains 3 elements, 3, 4 and 5. So the insertion and deletion will have to take place at a specific end. So let's suppose this is the head position or the head node. So you can perform, or I should say you can push or you can pop out at an element at a specific end. So in case of arrays, we do have a specific end because we have the index positions. So we can only insert and delete from the last position. But in case of list, we have 2 ends. One is the head and another one is the tail. So we can perform push and pop functions at either of these ends. It is totally our own choice. But this one is a more preferable way, because in this case, let's suppose this is case 2. In case 2, if you want to insert an element or if you want to delete an element, then you will have to traverse through this whole linked list. Suppose this linked list has n nodes, so you will have to traverse along the n nodes, and then you can push or pop at this end. So this is going to take the time complexity of O(n). And in this case, we do not need to traverse through the whole linked list. We can push or pop at the head position, or we can just say that this is the top position of our stack. So we will use the term top in this case. So in case of top, the time complexity will be big O of 1, which means that it will just take 1 second, or it just take the time complexity of 1 to just push or pop at the beginning of the linked list. So let's now implement the push and the pop functions, and we will perform these operations at the starting or the top position. So in the IDE, the first thing that we are going to do is we will first create a structure node. It will have the data and a next pointer, and in this case we will also create a top structure pointer, and initially the value of top will be equal to null, because our linked list, or I'm going to write here our stack, is empty initially. So the value of top will be null. So let's now make some push function calls here, like we have done in the previous tutorial of stacks as an array implementation. We're just going to do the same steps here. Let's push these elements 3, 4, 5 and 6 into the stack. So let's now create the function, the definition of this function push. Since the function push will not return anything, we are going to write it as void push, and since it is accepting an integer value, I will take it as int x. In the push function, we are going to create a new node, because when we want to add a particular if we want to push a particular element in the linked list, we will have to create a new node, and we will just create a function get new node that will allocate the new node in the memory, and it will return a pointer reference to it, and it will get stored in this new node variable. So let's now create this get new node function, since it will just return a struct node pointer, or I should write only node pointer here, because it is going to return a pointer reference to the new node. I'm going to write node pointer, then the name of the function get new node, and since it is accepting an integer, I will write it as int y. So let's now create a pointer to a structure, and let's name it as ptr separated by comma. You can create structure pointers as many as you want. You can create it here. So now we are going to use this new keyword, which is the default keyword, and this keyword is used to allocate the node dynamically. So this line will just allocate the pointer, the structure pointer, in the memory dynamically, and new operator is used, and this is a new operator, or you can say the new keyword, which is used to allocate it dynamically. You can also use the malloc function, but malloc function will just allocate the node permanently. So that's why we are using new pointer. You can also use the malloc function. So the next thing what we are going to do is we will just assign the data to this node as y, and then we will return this pointer. So return ptr, and when we will return this pointer, it will get stored in this new node pointer structure. So we will have to define a new structure pointer, which is new node, and so the reference that comes from this get new node function gets stored in this new node structure pointer. So the next step is to create the links. We know that whenever we want to push an element into a linked list, so let's suppose initially my linked list look like this. So let's suppose I want to add a new node at this end. So first of all, I will allocate this new node in the memory that we have already done using the get new node function. The next step is to create the links. So to create the links, first we will make the new node, the next pointer of new node, point to this top node, and then we will assign the new node as the top node. So I'm going to create links here. Links are just pointers. So the step 1 is to assign the next pointer of the new node, as the top node. And the next step is to assign the new node as the top node. And now what we are going to do is we are going to create another structure pointer TRV. TRV stands for traverse, and this pointer is basically used to traverse through the linked list, or I should say the stack, which we are implementing using a linked list. And this TRV, we will use it to traverse through our linked list. So the condition will be until and unless the value of TRV is equals to null. We are going to run this while loop, and we are going to use the TRV structure pointer to display our stack after every push function call. So we are going to write it like this, and after every displaying we will just change the structure pointer TRV to point to the next structure using this line. So this line basically assigns TRV to the next node, and then it will display its data, and this will go on and on until and unless the value of TRV structure pointer becomes equal to null. So this is our push function. So let's run this program and see the output. So after every this function call, we will also write an endl statement so that we can clearly distinguish how our stack will look like after each push function. So I'm going to write it like this. So let's run this program and see the output. So now you can see the output here. First, when we have in this line, we have pushed 3 into the stack, and then at the beginning of our stack we have inserted 4, then 5, and then 6. So we have successfully created the push function, we have successfully created our stack, and we have done this using linked list. So the next step we are doing is we are going to create a pop function, and this time the pop function is not only going to just traverse to the linked list, or we are not going to use this pop function only to display the data in the while loop, but this time we are going to delete the node at the beginning of our stack. So you can see that, let's suppose this is my linked list, and now I want to perform a pop function. Pop means delete. So what I will do is, first I will assign this top pointer to point to the next structure. So first step is to assign top as top next, and now we will have to delete this whole node. So for deleting this node, we will have to get a reference to it, because the top pointer has changed its reference from this node to this. We will have to save its reference first. So we will create another pointer by the name save, and we will assign it as top first, and then we will change the reference of top. So we are going to use the delete keyword or the delete operator, and this delete operator is used to delete a particular node from the main memory. So we will delete this save structure. So this is how our pop function will look like. So let's implement this. So after this pop function, we are going to push 1 into the stack, So let's write the pop function here. Since pop is also not returning anything, it is void. So the first step is to save the instance of the top pointer, because we will have to change this top pointer to point to the next structure. And we are doing this because we want to pop out the element, the first node. So we will have to change the top pointer, and then we will use the delete pointer. We will use the delete keyword to delete this saved node. So this will delete, or you can say this will pop out the first element of our stack. So this save is the structure pointer. So here we will write that save is a structure pointer. And this is a very simple program, and you can see that in the pop function, when we will call the pop function, it will pop out the first element of the stack, and then after the push function it will just push 1 into the stack at the beginning of the stack. So the main principle of LIFO is followed in this linked list, so we can call it as a stack now. So let's now run this program and see the output. So now you can see the output here. First 3 is displayed, then after 4, 5, 6 has been pushed, the pop function is called, and pop function will pop out the first element from our linked list, which is 6 here. You can see that 6 is popped out in the next line, and we have pushed 1 into the stack. So you can see that 6 is not here because we have popped out. We have used a delete keyword to delete this particular node. And remember to change the reference of the top pointer so that it will point to the next structure. So that's all in this linked list. So thanks for watching.